Welcome, ladies and gentlemen of geometry, to section 4.3. Today we're going to be learning about AAS and ASA congruence. We're moving on to Thanksgiving, so there's not a lot of Thanksgiving-themed things, so we're doing Charlie Brown. Hope you enjoy it. Now, ASA, we've already learned about SSS. SSS we learned was side, side, side. We also learned about SAS, side, angle, side. Anytime we have an S, it stands for side. Anytime we have an A, it stands for angle. Therefore, ASA is angle, side, angle. Now, it's really important to consider that this side needs to be sandwiched between these two angles. So if we have two angles, okay, there and there, the side is in between those two angles. Just as the ASA sandwiches the S in between the two A's, so the side needs to be sandwiched between the two angles. So let's break this down here. If we have this triangle here, and we're trying to see if it's congruent to the other one, what do we need to know? Well, first, we need to know that, let me get my color change here. We need to know that AC is congruent to FE. So we have a given side. What's next? Well, if we have a side, we have to have two angles sandwiching it. So we need this F, angle F, to be equal to angle A. And then we need this angle C. If this has two little lines, this one needs two little lines. And this is angle E. So those angles need to be congruent. And then if we have all that established, then we can say that the two triangles are congruent to each other. So angle or triangle A, B, C. I started at the red. I went to the non-given, and then I went to the blue. Is going to be congruent to, I start at the red, I go to the non-given, then I end with the blue. You have to go in the same order, F, D, E. Don't just go in alphabetical order and be like, oh, I went A, B, C, now I got to go D, E, F. No, you have to start with the same angles and go in the same order for both. Now, how is this possible? That we don't have all the sides given and all the angles given, and yet we're able to determine they're congruent? Well, it's because there's no other triangle you can make once you've been established with this frame. This frame ensures that this angle will be the same no matter what. Okay? So this frame establishes that these two triangles will be the same no matter what. So as long as you have that in place, then you're going to have the same triangle. So we'll go ahead and jump to example 1. How do you do these types of problems? We have two triangles here, and we're asked if ACE is congruent to DOG. So what I like to do is first I like to label. So I have my two triangles here. They're already separated, so that's pretty easy. But now I want to label. So here I have an angle. Let me go to, I like these colors. So I have an angle. I have a side. Okay, first I need to match these up. So this angle matches up with this angle over there. And I'm going to write this one as an angle. This purple side corresponds to this purple side. So I'm going to write S and S. And then we have C and G. Both are red lines, and that's an angle, a given angle that we know are congruent. Are they both sandwiched? ASA, yes, this is sandwiched. ASA, this is sandwiched. Okay, and what do I mean by sandwiched? An alternative to not being sandwiched, just so you know what I'm talking about. Let's say we're given an angle. And then we skip this side, and we go to this side, and then we have this angle right here. This is not angle, side, angle, because it skips a side. It has to be sandwiched between the two angles. This one is actually angle, angle, side, which we will learn about in just a second. So just keep that in mind. It has to be sandwiched between the two angles. So is ACE congruent to DOG? So ACE goes from the two blue, and it ends with, well, it goes to the red and then ends with the non-given. So does DOG do the same thing? DOG starts with the non-given, so no. These are not congruent. What about CEA? What about CEA? Where's CEA? Okay, we start at the red, we go to the non-given, and we end with the blue. Okay, that's CEA. And then GDO, we start at the red, we go to the non-given, and we end with the blue. Okay, so this one's yes, because of angle, side, angle, which we've already talked about. So that's example 1. Now we're moving on to angle, angle, side theorem. Or we can also call this side, angle, angle. You can go in reverse. So how do we establish this? Well, first thing we need to know, let's go back to these colors. First, we need to know that BC is congruent to FE. Okay, we got to have the side. I mean, technically it doesn't matter which order we go in, but now we need to have an angle. So we need this side, this angle here, angle B and angle F, need to be congruent. And then we also need another angle. So in this case, it's angle D, congruent to angle A. Now, once we establish this, then we can say that the two triangles are congruent. So let me use green. So we have triangle. Let's go blue to purple along the red side. So we have A, B, C, congruent to blue to purple, and on the red side, we have triangle D, F, E. Again, just don't go in alphabetical order. Now let's apply it. Are these two triangles congruent? So we have to decide if they're AAS. Now, first off, why is this AAS before we get into the example? It's AAS because we go from an angle, we skip a side, but that's okay if we skip a side, as long as we don't skip a side and an angle, as I talked about in last video. Then we go to another angle, so that's A, and then we end up on a side. The very next thing is a side. If you go in reverse, we go side, then we go to the angle, and then we go to another angle. It's okay if we skip one side, as long as you don't skip a side and an angle, and that's how you do ASA, or AAS, sorry. You know what I meant. Moving on to example 2, are the two triangles congruent? Name them, if so. So first we need to see, let's label our angles. We have this one matches this one, we can call that AA. Then we have this angle matches this angle, we can call that AA. Notice how I'm like working my way around the triangle. Okay, be strategic. Don't just skip around all over the place because it doesn't help you. Then we have a side that matches this side, so we have side. So this is side, angle, angle, or angle, angle, side, because it goes in order. We don't skip more than two things, or we don't skip two things, I should say. We don't skip more than one thing. So we get angle, angle, side, yes. And what are the two triangles? Let's go to purple to blue to red. So we go purple, triangle is CAT, is congruent to purple is the purple angle for the other triangle is N, and then with the blue angle is F, and then we go to I and FI. So triangle CAT is congruent to NFI. Example 3, and this is our last one, is triangle XYZ congruent to LMN. This one we actually have a little bit of work. So we have, actually not much, if not name the congruent triangles. So first we should identify, okay, this side matches this side, that's a side. We have this angle matches this angle, that's an angle. Notice how I'm going around clockwise this time. And then I have an angle matches another angle, and that's an angle. Okay, so we have SAA, we don't skip both angle and a triangle, or angle and a side, so we're good. These are both SAA, but now we just need to make sure if they're labeled correctly. So we have XYZ, let me change colors. So we have XYZ, we start at the bottom left, go to the top, and end at the right. Congruent to L, L's up here. L does not match or correspond with angle X, so these are not congruent. No. So the ones are congruent by SAA are, we can say triangle, bottom left. XYZ is going to be congruent to triangle N, bottom left, to top, L, and then M. So that is the correct way to write these congruent triangles. That's all I have for today. Hope to see you next time where we learn about more triangle congruence stuff. Thanks, geometry students. Hope you enjoyed, and thank you for watching.